Let me ask you something. Has your doctor, or anyone you trust, ever looked you in the eye and said, "You need to cut out the bread, stop eating rice, potatoes are off the table"? And did you walk home that day feeling like someone had taken something from you? Not just food, but your culture, your comfort, your routine. You are not alone in that feeling. And here's what I want you to hear before we go any further. That advice, while well-intentioned, is incomplete. And in many cases, it's setting people up to fail before they even begin. Because the truth is this, it is not always what you eat that matters most. Sometimes what matters even more is how you prepare it, what you pair it with, what order you eat it in, and when you eat it. The same food, handled intelligently, can produce a completely different response inside your body. And that is exactly what we are going to talk about today. Welcome back, everyone. I'm Dr. David Aid, and this channel exists for one reason: to give you the kind of practical, evidence-based health information that actually helps you live better, starting today. Now, bread, rice, potatoes, these are not exotic ingredients. They are not fad foods eaten by a small niche of people once a week. They are the cornerstones of human nutrition, the staple foundations of nearly every cuisine on Earth. For billions of people across generations, these foods are not just meals. They are identity. They are family dinners, cultural celebrations, and everyday nourishment. And yet, when someone receives a diagnosis of type 2 diabetes or prediabetes, the very first advice they are often given is to eliminate them entirely. Now I understand where that advice comes from. Carbohydrates raise blood sugar. These foods are carbohydrates. So, remove the carbohydrates. The logic sounds clean. But medicine is not always that simple. And more importantly, advice that cannot be realistically sustained does not help anyone in the long run. What I want to offer you today is something different. Not a list of things to avoid, but a set of strategies grounded in peer-reviewed science that allow you to continue eating the foods that matter to you while fundamentally changing how your body processes them. We are going to cover 6 specific strategies today. Each one is supported by clinical evidence. Each one is practical enough to start using immediately. And together, they add up to something powerful, a way of eating that works with your body, not against it. Before we go any further, I do need to say something important. Everything I share here today is for general educational purposes and is based on peer-reviewed research. I am not your personal physician. Before you make any changes to your diet, especially if you are on insulin or blood sugar lowering medications, please speak with your own doctor. Some of the strategies we will discuss today can meaningfully lower your post-meal glucose levels. That is a good thing. But if you are on medication, your dosage may need to be reviewed. Please take that seriously. All right, let's get into the science. The first strategy is one that most people managing diabetes have never heard about. And when I share it with patients in a clinical setting, it almost always catches them off guard. Not because it's complicated, but because it's so simple and so counterintuitive. It's called resistant starch. To understand why resistant starch matters, we need to briefly understand what happens normally when you eat a starchy food. When you eat freshly cooked white rice, white bread, or a standard serving of potatoes, the starch in those foods is broken down rapidly by digestive enzymes in your small intestine. It gets converted into individual glucose molecules, and those molecules enter your bloodstream quickly, producing what we call a glucose spike. Your pancreas responds by releasing insulin to manage that glucose surge. And in a body where insulin is working well, that system handles it efficiently. But in someone with type 2 diabetes or prediabetes, that insulin response is sluggish, or the body's cells don't respond to it properly. So that glucose spike stays elevated longer than it should. And those repeated spikes, meal after meal, accelerate insulin resistance, stress the insulin-producing cells in the pancreas, and drive the progressive worsening of the condition over time. Now, resistant starch behaves entirely differently. As the name tells you, It resists digestion. Your digestive enzymes cannot break it down efficiently in the small intestine. So instead of being rapidly converted to glucose, resistant starch travels largely intact all the way to your large intestine. And there, your gut bacteria ferment it. The byproducts of that fermentation are compounds called short-chain fatty acids, and particularly one called butyrate. And butyrate does several things that directly matter for blood sugar control. It improves insulin sensitivity in peripheral tissues, meaning your muscle cells and liver cells become more responsive to the signal telling them to take up glucose from the blood. It reduces systemic inflammation, which is one of the underlying drivers of insulin resistance, and it supports the integrity of your intestinal lining, reducing what's called leaky gut, which contributes to metabolic dysfunction. So resistant starch is not simply a carbohydrate that raises blood sugar less. It is actively working to improve the biological problem that makes blood sugar control difficult in the first place. That is a meaningful distinction. Now, and here is where this becomes immediately practical, you can significantly increase the resistant starch content of foods you are already eating without buying anything new and without changing your diet in any dramatic way. Here is how. When you cook a starchy food, rice, pasta, potatoes, and then allow it to cool completely, something happens to the physical structure of the starch. The heat of cooking loosens and softens the starch molecules. But as the food cools, particularly to refrigerator temperature, around 4 degrees Celsius, those starch molecules reorganize. They form tight, crystalline structures that your digestive enzymes cannot break down as efficiently. This process is called retrogradation. The food has been physically transformed. It looks the same. It tastes very similar. But metabolically, it behaves more like fiber than like rapidly digestible starch. Multiple studies have confirmed this. Cooling cooked rice or cooked potatoes in the refrigerator for approximately 24 hours significantly increases their resistant starch content compared to freshly cooked versions. And here is the part that surprises most people. When you reheat that cooled food, a meaningful portion of the resistant starch is preserved. The retrogradation is not fully reversed by reheating, so you get food that tastes close to what you are used to, with a substantially different metabolic effect. Clinical studies show that eating cooled and reheated rice or potatoes produces measurably lower post-meal blood sugar spikes and lower insulin responses compared to eating the same foods freshly cooked. The same food, the same portion, just prepared differently. And the blood sugar response looks meaningfully different. Even bread that has been frozen and then toasted has a higher resistant starch content than fresh bread. So if you keep a loaf in the freezer and toast it from frozen, that is actually a smarter metabolic choice than fresh bread, all else being equal. If you eat rice regularly, cook a larger batch, refrigerate it overnight, and reheat what you need. The same goes for potatoes. These are not dramatic lifestyle changes. They are small preparation habits with real metabolic consequences. Beyond the cooking and cooling strategy, there are foods that are naturally rich in resistant starch worth incorporating whenever possible. Legumes, beans, lentils, and chickpeas are the most concentrated natural source and also contain soluble fiber that further slows glucose absorption. Steel-cut oats contain meaningful resistant starch, far more than instant oats. And slightly underripe bananas, the ones with a firm texture and a hint of green, contain significantly more resistant starch than fully ripe ones. As a banana ripens, its resistant starch is progressively converted into readily digestible sugars. The firmer the banana, the gentler it is on your blood sugar. The second strategy is food pairing, and this is one of the most clinically impactful changes a person can make without changing what they eat, only what they eat alongside it. Let me start with a basic principle that is easy to understand. Carbohydrates eaten in isolation produce the sharpest blood sugar responses. When starch enters your digestive system with nothing else to slow it down, the glucose hits your bloodstream quickly and peaks sharply. But when you eat that same starch alongside protein, fat, fiber, or an acidic component, you change the entire metabolic equation. Let's go through each one. Protein pairing. The evidence here is particularly strong. A meta-analysis looking at over 150 controlled trials found that adding protein to a carbohydrate-containing meal reduced the glucose area under the curve by up to 50% in the study participants. That is not a modest finding. That is cutting the blood sugar impact of a meal in half simply by including a protein source alongside the carbohydrate. Part of the mechanism involves a hormone called GLP-1. You may have heard of it. It's the same hormone targeted by some of the newer diabetes medications. Protein stimulates the release of GLP-1, which slows gastric emptying and smooths the delivery of glucose into the bloodstream. The glucose still arrives. It just arrives more slowly and evenly, rather than in a surge. So what does this look like practically? It means eggs with your toast, rather than toast alone. It means rice with chicken, beans, or fish, rather than rice as a standalone side. It means adding Greek yogurt, cottage cheese, or a handful of nuts to a meal that would otherwise be dominated by carbohydrate. Dietary fat works through a similar mechanism. Fat slows the rate at which food leaves the stomach, extending the window over which glucose is absorbed and reducing the sharpness of the peak. This is the biological reason why potatoes cooked with olive oil or eaten with a little butter produce a gentler blood sugar curve than plain boiled potatoes, and it explains why rice and beans together is metabolically superior to rice alone. The fat and protein from the beans are changing the kinetics of how glucose enters your blood. This does not mean adding large amounts of saturated fat to every meal. It means using healthy fats, olive oil, avocado, nuts, as part of your normal meal composition, rather than eating carbohydrates in isolation. Acidic components. This one surprises most people. Adding vinegar, lemon juice, or lime juice to a starchy meal can measurably reduce the rate at which that starch is broken down by digestive enzymes. The acetic acid in vinegar also improves insulin sensitivity in muscle tissue and can directly reduce glucose production by the liver. The practical applications are straightforward. A simple vinaigrette dressing on a salad, eaten with your meal. A squeeze of lemon over your rice or grain dish. Lime juice on your beans. A small amount of apple cider vinegar diluted in water before a meal, which some research has examined as well. Fermented foods, kimchi, sauerkraut, miso, natural yogurt, contain organic acids from the fermentation process that exert a similar effect and also support the gut microbiome in ways that improve long-term metabolic health. So when you are building a plate, think of it this way. Never let a starchy food sit alone. Give it a protein. Give it a fat. Give it some fiber. Add something acidic if you can. Each of those elements is doing metabolic work that benefits you. Now we come to what I consider one of the most remarkable findings in recent metabolic research, and one of the simplest changes you can make. It is not what you eat. It is not what you eat it with. It is the order in which you eat it. This is called food sequencing, and the evidence behind it is genuinely impressive. Here is what happens when you begin a meal with bread, rice, or any rapidly digestible starch. The carbohydrate hits your digestive system immediately, with nothing to slow it down. The glucose surge begins within minutes of your first bites. The peak arrives fast and climbs high. Now here is what happens when you start that same meal with protein and vegetables first, and save the starchy food for the end. The protein and fiber from the vegetables you ate first have already begun slowing the rate at which your stomach empties its contents into the small intestine. So, when the starch finally arrives, from the rice or bread or potato you ate last, it enters a digestive environment where gastric emptying is already slowed. The glucose is released gradually. It enters the bloodstream steadily, rather than in a surge. The clinical evidence on this is striking. A randomized controlled crossover trial conducted specifically in people with type 2 diabetes found that eating protein and vegetables before carbohydrates, compared to eating the same foods in the opposite order, reduced the glucose area under the curve by 40%, and the insulin response was 31% lower. Same meal, same foods, same portions, different sequence, and a 40% difference in the blood sugar curve. A separate study conducted in Japan using continuous glucose monitors in healthy adults confirmed the same pattern. Eating rice at the end of the meal rather than the beginning significantly reduced post-meal blood sugar excursions. The practical application of this is genuinely simple. When you sit down to eat, start with your salad or your vegetables, then move to your protein. Then, at the end, enjoy your rice, your bread, or your potatoes. If you are at a restaurant that brings bread to the table before the meal arrives, you do not need to ask them to remove it. Simply leave it there. Drink your water. Start with your salad when it comes. Eat your protein when the main course arrives. And if you want the bread, have it at the end. This one behavioral change, no change to what you order, no change to your portions, can meaningfully flatten your blood sugar curve at every meal. The fourth strategy is something I recommend to virtually every patient I see managing blood sugar, and the research on it is consistently impressive for how large an effect such a small behavioral change produces. 10 minutes of walking after a meal. Not a gym session, not a 45-minute jog. A 10-minute walk, around the block, down the hallway, around your living room if needed. A randomized controlled trial showed that a 10-minute walk, taken within 15 to 30 minutes of finishing a meal, produces a meaningful reduction in post-meal blood glucose compared to sitting. The size of that reduction from such a brief activity is something that catches people off guard every time. The mechanism is specific and well understood, and it centers on a muscle that most people have never thought about, the soleus muscle. The soleus is the deeper of the two calf muscles. It runs from just below the knee down to the heel, and it has a metabolic profile that is quite remarkable. The soleus is composed predominantly of slow-twitch muscle fibers, the type built for sustained low-intensity activity. This means it can remain active for extended periods without fatiguing. But the critical detail is this: skeletal muscle contraction during movement takes up glucose from the bloodstream through a pathway that does not require insulin. It is what researchers call insulin-independent glucose clearance. The muscle simply absorbs glucose directly as fuel while it is contracting. What this means for you is powerful. Even if your insulin response is sluggish, even if your cells are insulin resistant, your soleus does not care. The moment you start walking, it begins clearing glucose from your blood independently of that system. It is, in effect, a glucose sponge that works regardless of your level of insulin resistance. The timing matters significantly. The earlier in the post-meal window you begin walking, the more effectively you intercept the glucose rise before it peaks. Aim for within 15 to 30 minutes of finishing your meal. If walking is not practical, any light movement helps. Standing while you clear the table, climbing a flight of stairs, light household tasks. Walking has been the most studied and appears to be the most effective, but the underlying principle is that any muscular activity after eating engages this insulin-independent glucose clearance mechanism to some degree. Build the 10-minute post-meal walk into your routine. Attach it to a meal you eat consistently, perhaps dinner or lunch. Make it a habit. The cumulative effect over weeks and months is substantial. The fifth strategy addresses the quality of the carbohydrates you are choosing, and I want to be careful here about what I am and am not saying. I am not telling you to follow a low-carbohydrate diet. I am not asking you to count grams. What I am asking you to think about is the physical structure of the carbohydrates you eat, because that structure determines almost everything about how quickly your body converts them into glucose. Think about what happens to a grain of wheat when it is milled into fine white flour. The grain, which once had a complex fibrous structure that digestive enzymes had to work through slowly, is ground into particles so small that enzymes can access virtually the entire surface area simultaneously. The starch breaks down almost instantly. White bread, white pasta, crackers, standard breakfast cereals, pastries, and instant oatmeal all share this characteristic. They are made from finely processed starches. Your body converts them to glucose rapidly, and if your glucose management system is already under strain, that rapid conversion overwhelms its capacity. Now compare that to steel-cut oats, or intact whole grains like barley, farro, or whole rye, or legumes, lentils, black beans, chickpeas. These foods have not had their physical structure disrupted by milling. Digestive enzymes have to work through intact cell walls and dense fibrous matrices to access the starch inside. That process is slow. Glucose enters the bloodstream gradually. The blood sugar curve is flatter. The insulin demand is lower, and the feeling of fullness lasts significantly longer. I often use this analogy with patients. Fine white flour is like sawdust thrown on a fire. It ignites instantly, burns intensely, and is gone in seconds. Intact whole grains and legumes are like logs on that same fire. They release their energy slowly and steadily, and they keep burning long after the sawdust is gone. The metabolic consequence of that difference, meal after meal, day after day, year after year, is enormous. When you are choosing carbohydrate sources, look for foods where the grain structure is still visible and intact. Steel-cut or rolled oats rather than instant. Brown rice or cooled white rice rather than freshly cooked white rice. Whole grain bread that is dense and chewy with visible grain texture rather than soft commercial bread that is essentially fine flour with coloring added. Legumes as often as you can work them in, and fiber deserves a special mention here. Soluble fiber, found in abundance in oats, legumes, and many vegetables, forms a gel-like matrix in the intestine that physically slows the absorption of glucose. Insoluble fiber adds bulk and supports gut motility. Both types support the gut microbiome and the short-chain fatty acid production we talked about in our resistant starch section. If you are adjusting your carbohydrate intake for blood sugar management, fiber should be the absolute last thing you cut. It is the most metabolically valuable part of carbohydrate-containing food. Its absence undermines everything else you are trying to do. The sixth strategy is about when you eat, specifically the timing of your last meal of the day relative to when you go to sleep. And the science on this is consistent and clear. Your body does not process glucose the same way at all hours of the day. Your insulin sensitivity, your cell's ability to respond to insulin and take up glucose, follows a circadian rhythm. It is highest in the morning and declines progressively throughout the day. By evening, your tissues are meaningfully less insulin sensitive than they were at breakfast, and the pancreatic cells that produce insulin are also less responsive later in the day. This means the same meal that would produce a moderate glucose response at noon can produce a significantly larger response at 9 o'clock in the evening, and there is a specific hormonal mechanism that compounds this problem. In the hours before sleep, your body produces elevated levels of melatonin, the hormone that signals to your body that sleep is approaching. Melatonin receptors exist on the insulin-producing cells in your pancreas, and melatonin directly suppresses insulin secretion through those receptors. So in the late evening window, you have a double disadvantage. Your tissues are already at their lowest insulin sensitivity for the day, and rising melatonin is simultaneously reducing your pancreas's ability to produce the insulin you need. The result is that a carbohydrate-containing meal eaten close to bedtime will almost always produce a worse glucose response than the same meal eaten earlier, and the elevated glucose has nowhere to go efficiently, staying elevated well into the night and disrupting your overnight metabolic recovery. The practical recommendation that research supports is straightforward. Eat your last meal of the day at least 3 hours before your typical bedtime. If possible, earlier is better. Some research suggests that finishing dinner by 6 or 7 in the evening and allowing a longer overnight fast has additional metabolic benefits, but the minimum target is 3 hours before sleep. If your work schedule, family commitments, or lifestyle means late dinners are currently unavoidable, I understand. This is not about perfection, but if there is any flexibility in your routine, shifting your dinner earlier is one of the highest impact timing changes you can make for your blood sugar management, and many people find that their fasting blood sugar the following morning reflects that change within a matter of days. Let me bring everything together for you now. You do not have to give up bread, rice, or potatoes. What you do need is a set of specific evidence-based tools that change how your body responds to those foods. 1. Cook your starchy foods, cool them overnight in the refrigerator, and reheat before eating. This increases their resistant starch content and produces a measurably lower blood sugar response. 2. Pair every carbohydrate-containing meal with protein, healthy fat, and fiber. Never eat starch alone. Each of those additions is doing real metabolic work. 3. Add an acidic element, vinegar, lemon, lime, to your meals to slow starch digestion and improve insulin sensitivity. 4. Eat your vegetables and protein first. Save the starchy food for the end of the meal. Research shows this simple sequence can reduce your post-meal glucose curve by up to 40%. 5. Take a 10-minute walk within 30 minutes of finishing your meal. Your soleus muscle will clear glucose from your blood through an insulin-independent pathway, regardless of your level of insulin resistance. 6. Choose carbohydrates with intact physical structure, whole grains, legumes, steel-cut oats, rather than finely milled flour products that digest almost instantly. 7. Eat your last meal at least 3 hours before bedtime to align your food intake with your body's natural circadian rhythm for insulin sensitivity. None of this requires you to give up the foods that anchor your meals and your life. It requires you to understand the biology well enough to make smarter choices and to work with your body rather than around it. Here is what I want you to hold on to when this video ends. Your body has not failed you. It has been doing the best it can with the information it has been given. Give it better information, applied consistently, and the response often begins faster than most people expect. Managing blood sugar is not about suffering through deprivation. It is about understanding how your biology works and meeting it where it is. If today gave you even one practical tool that your appointments haven't had time to cover, I am genuinely glad. That is exactly why this channel exists. If this helped you, please take a moment to hit the like button. It takes 1 second and it means the world for helping this information reach the people who need it most. If you are not subscribed yet, now is a great time. We put out new evidence-based health content every week, and I would love to have you as part of this community. And leave me a comment below. Tell me which of these 6 strategies you are going to try first. Or if you have a question, drop it down there. I read them. Share this with someone you know who's been told only what they cannot eat, without being told how to eat what they love more intelligently. They deserve this information too. I am Dr. David Aid. I will see you in the next one. Take care of yourselves.